is a lesson video of chapter 4.2, which is about molecular shape and polarity. In this lesson video, we are going to learn about explain the bond polarity and dipole moment. Molecular polarity is known as a physical property of compound which relates the other important physical properties such as melting point, boiling point, solubility, and intermolecular forces of attraction. To understand molecular polarity, we will first look at the individual bond between atoms and the entire molecule. To do this, we are going to explore more about what is bond polarity and dipole moment. Let's say that we have a hydrogen molecule as an example. Both hydrogen atoms are sharing their valence electrons to form a covalent bond. The question is, what is the bond polarity of the covalent bond formed by this molecule? Now, let us learn more about bond polarity. By definition, bond polarity is a term that describes how the electron density are distributed in a covalent bond of a molecule. There are two types of bond polarity. One is called nonpolar bond and another one is polar bond. A nonpolar bond is formed when there is equal distribution of electron density between atoms in a covalent bond, while a polar bond is formed when there is unequal distribution of electron density between atoms in a covalent bond. Let's say if we have molecules such as hydrogen, hydrogen fluoride, water, carbon dioxide, and any other molecules. How do we determine the bond polarity of the molecule? Well, the electronegativity of atoms that are bonded together will determine whether a molecule has polar or nonpolar bond. As we have learned before this in the periodic table chapter, the electronegativity of an atom, or usually being called as En, is the ability of atom to attract electrons towards itself. From the periodic table, we know that the trend for the electronegativity of an atom across the period is increasing and decreasing down the group. Since fluorine atom has the highest electronegativity value, which is nearly 4.0. Therefore, fluorine is the reference atom for electronegativity trend. For a bond to be classified as polar or nonpolar bond, we need to look at the differences between the electronegativity of atoms bonded together in a molecule. Let's say that we have a diatomic molecule with similar atoms such as hydrogen molecule. Since both hydrogen atoms has a similar magnitude of electronegativity, hence there is no electronegativity difference between both atoms. So, both hydrogen atoms will equally share the electron density in the bond. Therefore, hydrogen molecule has nonpolar bond. The next example is, let's say that we have a diatomic molecule with a different atom such as hydrogen fluoride molecule. Since the atoms bonded are different, therefore the electronegativity of both atoms are different. As we can see, the electronegativity of fluorine atom is higher than hydrogen atom. Because of this, the fluorine atom will attract more electron density towards itself, making the electron density not equally distributed. As the result, a region of separation of charge is formed. In this case, the high electronegative atom of fluorine that attract more electron density towards itself will have partial negative charge region, and usually we indicate it with delta negative symbol. While for the low electronegative atom of hydrogen, it will have partial positive charge region on itself, where delta positive symbol is indicated. The distribution of electron density is usually indicated by an arrow, which is called as a bond dipole. The direction of bond dipole is always pointing towards the more electronegative atom in a molecule. In this case, it will pointing to fluorine atom. This arrow is not like a normal arrow. The positive end here is known as delta positive region, and the arrow here is known as delta negative region. If we look at the molecule with the electron density cloud, the delta negative region is known as electron-rich region because fluorine atom attracts more electron density towards itself, while for delta positive region is known as electron-poor region because less electron density is distributed on this region. As electron density are not equally distributed, the covalent bond between hydrogen and fluorine atom is said to be a polar bond. A question to ask: can bond polarity be measured mathematically? Well, the answer is yes. We can measure the bond polarity mathematically by using a dipole moment. Dipole moment is a measurement that shows the magnitude of the molecular polarity. Usually, dipole moment is presented by a mu symbol. By definition, dipole moment is defined as the product of the magnitude of the charge and the distance that separates the center of the delta positive and the delta negative charge. The mathematical formula is mu is equals to Q times R, where Q represents the charge in coulomb and R represents the distance between charge. From the example that we have previously, hydrogen molecule has low and similar electronegativity value, where they divide the electron density equally and forming a same partially positive charge on the molecule. So, both atoms has no differences in separation of charge, as we can see from the electron density cloud picture. Therefore, this cause the dipole moment is equal to 0. For HF molecule, because there is a separation of partially positive and negative charge on the molecule, the dipole moment can be calculated. From the electron density cloud picture, we can see that the magnitude of delta positive and negative can be multiplied by the distance between the center of the charge of hydrogen and fluorine atom. Hence, the dipole moment is not equal to 0. In conclusion, mu is equals to 0 when the molecule has non-polar bond, but the mu is not equal to 0 when the molecule has polar bond. We can only calculate the dipole moment for molecule with polar covalent bond. How about the other molecules such as oxygen, carbon dioxide, and water? Which of these molecules has polar or non-polar bond? Pause this video and try to figure out the answer. Let's start with oxygen molecule. Well, oxygen has same atoms bonded together, and this causes no electronegativity difference between the atoms. The electron density are equally distributed, so oxygen molecule has non-polar bond. Carbon dioxide has different atoms bonded together. The electronegativity of oxygen is higher than carbon, so oxygen atom attract the electron density closer to itself, making the electron density unequally distributed in the covalent bond. Therefore, carbon dioxide molecule has polar bond. Water has oxygen and hydrogen atom bonded together, and these cause the electronegativity differences. Since oxygen is more electronegative than hydrogen, therefore oxygen pull the electron density stronger towards itself, making the electron density unequally distributed. So, water molecule has polar bond.